Welcome. Thank you for coming. Thanks for coming out to Seattle too. It's not that great outside right now, but I'm telling you the summers here are gorgeous. So please come back and visit. Today we're going to be talking about securing the exchange of sensitive data. My name is Robert Mooney, and I'm a consultant with Casaba Security. Casaba is a security consulting firm. We're a consulting member of the Microsoft SDL Pro network. Much of our work involves security analysis, development, and testing. My role is in infrastructure and application review. I spend most of my time examining application architecture and implementation. I have a background in commercial software development, and my focus as of late has been in securing cloud-based services running in Windows Azure. So the focus of this presentation is things you can do to reduce your risk of compromise when exchanging information with your colleagues. We're going to be talking at a very high level, a very broad level, 10,000-foot view, discussing what data exchange is, what our goals are in securing data exchange, and we'll touch on some recent data breaches and what you can do to help prevent them. I'll give my opinions on some ways we commonly share data, and I'll also share some suggested requirements to use when evaluating solutions geared primarily towards cloud-based solutions. So let's get started. What do I mean when I say data exchange? I'm talking about, for the purposes of this discussion, structured information transferred between individuals and organizations. For all intents and purposes, data exchange began to take shape back in the 1960s through electronic data interchanges, which provided transport mechanisms to organizations who wish to share data. Until the late 80s and 90s, much of that data was shared between organizations over these networks. And then, obviously, data began to be exchanged over the internet. So how many people remember TimeNet? Anyone? TimeNet, yeah. Now defunct. In those days, we didn't really think about the mechanism that was transporting our data. We just trusted it. So our goals in securing data exchange are to maintain privacy, prevent data theft, and adhere to any legal requirements. That's kind of general. I'm sure you have other goals, but in general, that's typically what we're looking for. We're also concerned with confidentiality, integrity, and the availability of our data. More generally, we're concerned about where data originates, where it goes, and how it gets there. And what we'd ultimately like to do is prevent a data breach. So this is certainly an appropriate topic for this week. This reminds me, if you haven't done so already, please disable the Java extensions in your browser. Right now, web-based Java attacks are hot and have infected a number of organizations recently, including Apple, Facebook, and Twitter. So let's define data breach. A data breach is sensitive data disclosed to unauthorized personnel either through malicious intent or by mistake. So this can be accidental disclosure, hacking, or insider theft. And sensitive data in our case is typically PII, so personally identifiable information. But it can also be intellectual property, financial information, credit card numbers, et cetera, in paper or electronic form. And obviously this talk is going to be geared towards the electronic form. Typically we're referring to data leaks, where the data is not lost, but electronically crosses a barrier that we thought to be secure, and so it's copied. And what we're looking at here are the publicly reported data breaches per sector in 2012, according to the Identity Theft Resource Center. They report that over 17 million records were exposed as a result of data breaches last year. And note, this is only what was reported by the organization or in the media, so you can only imagine what's unreported. I'm sure everyone has heard about Advanced Persistent Threat 1. Kirk touched on that earlier this morning. It's our new enemy on the cyber warfare front. So for those of you who haven't heard about it, consider that we now have strong evidence that foreign entities have been infiltrating our cyber defenses for years. It's pretty scary stuff. Again, Apple, Facebook, and Twitter have all reported being hacked in recent weeks, and who knows what sensitive information they lost, although they claim that they haven't. So it's becoming increasingly apparent that we need to protect our data. And it's just a fact of life in the connected world that we're living in. And so what does this all mean? And simply, it's don't be a statistic. But this has some challenges because the data that we're handling contains sensitive information, and we need to be sure that we're not going to be compromised. Okay, so how do we protect our data? One common thread amongst the breaches that the ITRC reports on is that encrypted data is not considered to be a data exposure. So if we leak encrypted data, they don't count it, unless it's password protected. So we're going to focus our efforts there. If we're the victim of a data breach and our data is encrypted, our exposure may be significantly reduced. But there are some caveats, and we'll get into those in a moment. So when I was a teenager, my friends and I used to take garbage from outside of the computer labs at a local unnamed university, not local in Seattle. And we'd take it to a conference room and scan it for interesting information. I was probably 13 at the time, but we would follow people in through secured doors and wander around. Nobody ever asked us a question. The trash bins weren't locked, and they seemed to be the most likely places for passwords, so why not? We thought we might find something interesting. And it was amazing how often we found passwords. And once we had an in, it was often very easy to obtain greater access, so even administrator access on some of these clusters. And we had access to everything, including student records, financial information. Imagine what I could have done if my interest had not been in learning Unix. So the problem with keeping data secure is that there are so many ways that it can be compromised. Network sniffing, shoulder surfing, disk, whether it's active or discarded, laptops, mobile devices, trash bins. Let's talk about the solution. So the solution starts with a great policy. Kirk also touched on this morning. A policy helps prevent bad things from happening. So it's responsible for keeping locks on the trash bins, providing security training, keeping workstations up to date with the latest security patches. And a security policy also includes a great incident response plan. And the incident response plan helps you to deal with issues that come up when the policy isn't enough and bad things happen. So how will you respond when your data is exposed, and what happens if it makes headlines? If you don't have a security policy and an incident response plan, you need one. If you're a covered state or federal organization, you know this pretty well. Policy can also drive contracts with third parties. And again, Kirk touched on this morning, super important. So my mom's an academic and can't help searching for her name on the internet just to see who's referenced her papers. Recently, she found her name on an operating room roster that was published on the internet. And she had had surgery a few months earlier, but the information was not something that should have been published. It was a HIPAA violation for sure. Fortunately, my mom's a reasonable person, sometimes, and gave the hospital a call. Ultimately, it was discovered that the third-party organization the hospital had been working with had accidentally published the roster to the internet, and the hospital was able to get them to remove it. So crisis averted, right? Well, not necessarily. So the problem, as I'm sure you know, is that once it's published on the internet, you can assume it's been cached. And it goes without saying, no matter what your organization is, we want to avoid this mess. And how do we do that? So there must be some incentive for external organizations to treat your organization's information with care. And you have to ask yourself, what's my organization's policy, and what is our policy with third parties? And strong words are nothing without enforcement. Fortunately, you don't need to have air gaps between rooms to have an effective, secure environment, but policy and contracts must be enforced, and they must be revisited periodically and improved upon. So many of the environments that Kasaba has looked at have been open. They have no lateral security. They don't restrict where people can go. People have access to a lot of different resources. And this makes sense from an operational standpoint because generally your organization wants to make it easy for you to do your job. But this also leaves us susceptible to attack. So let's say you work in a proactively secure environment. Your organization has a great security policy. You have great contracts in place with third parties. You have secure building access. You have a shred bin. You religiously place documents there. Your machine is up to date with the latest security patches. And you've even got data loss prevention software deployed. All these technologies, policy, contract, data loss prevention technology can assist us in keeping sensitive data secure, but ultimately it comes down to us. Nobody is going to take responsibility for securing your work but you. An adage of the security industry is that you're only as secure as your weakest link. And as humans, we tend to be the weakest link. In the dumpster diving example I gave earlier, if it wasn't for someone having stored their user passwords or printed them out, we never would have found them. So going forward, we're primarily going to focus on what you can do as an end user and evaluator of possible mechanisms that can transmit your data securely. Again, we must take personal responsibility and we must be informed. So here are some general tips. These are probably pretty obvious, but they're important nonetheless. So first, lock your workstation. It's amazing how many times I've been in an environment, it's amazing how many times I've been in an environment and watched people walk away from an unlocked machine. A lot of times there's organizational policy that's pushed down to your machine that will lock it after a certain amount of time, but you should still probably lock it when you walk away. It's really easy for somebody to walk up and just start using your resource. Protect your passwords. This is common knowledge these days, but it's still amazing how many times we walk into an organization and see people with their SQL passwords taped right to their monitor. At worst, keep it in your pocket. At best, keep it in your pocket. It's important to make sure that nobody can see these kind of secrets. Also, on that note, use a strong password. Kind of outside of the scope of this, but strong passwords are important too. Use encrypted file systems. For Microsoft Technologies, they have the encrypted file system, which is a pretty great distributed secure file sharing mechanism. And they also have BitLocker, which is great. For Mac OS, there's File Vault 2. Make sure you're using 2 and not 1. 1 has some known weaknesses. And on Linux, there's dmcrypt. Also, there's TrueCrypt, which will work across platforms. Securely delete your files. So sensitive information should not be lying around. So make sure that you use a secure eraser. So there's Eraser for Windows, Shred and Secure Delete for Linux, and Permanent Eraser for Mac OS. Also, this has been mentioned a few times today in a few talks, is minimize the amount of sensitive data you're sharing. So ask yourself, is it necessary for me to extract all this information from this database before I send it out to my colleagues? And the focus of this presentation is really on this last item, transfer documents securely. So we're talking about transferring documents between your colleagues. So it's important to understand a few concepts first. Data in motion and data at rest. For all intents and purposes, when we're talking about data in motion, we're talking about how the data gets there. So the actual transfer of the data, the process of copying or uploading a file. When we're talking about data at rest, we're talking about how data is stored. So where it resides on a file system, on your disk drive, et cetera. And it's important to protect the data being shared as well as the way in which it is shared. So meaning it's important to protect the data in motion and at rest. And how do we do that? So let's look at some common ways that data is shared. This is based on an informal survey of professionals. Not surprisingly, these are all susceptible to compromise and indeed have been compromised. So kind of at a high level, USB, it's not a bad choice for sharing, but unfortunately it doesn't scale well. If you're not using USB for sharing with more than a few people, you're probably not going to be using it. You're probably not going to be using it. So you still want to encrypt the documents that you have here at rest. In terms of cloud services, these obviously are going to vary. I've seen claims from an unnamed provider that they keep encrypted documents that are uploaded to their service, and the interesting bit is that they also keep the encryption keys for those documents offline. So they keep your encryption keys. To me, that's like giving somebody your house key, and then having all of their friends be able to access it anytime they want. So personally, I would still encrypt my data before using a lot of these services. Email. Consider that your administrator can typically read what you're doing, can read any document, and who knows who might be reading your mail if you're sending it through Google or Microsoft. So FTP is completely broken, don't use it. Don't use FTP. It's fundamentally flawed. It's broken. But there are solutions, so don't worry. We're getting there. SFTP is a better solution. It's better than FTP, but it's not infallible. You can set up public key cryptography with SFTP, and that's much better than password-based authentication. Typically, password authentication is going to be weaker for all services than some form of public key cryptography. File shares. Another really popular way to exchange files, but it's also a really great way to get owned. So unless you're using a distributed secure technology such as EFS, I'm going to go out on a limb and say avoid file shares as well. Typically, file sharing is difficult to secure properly, but if you know what you're doing, go for it. Just make sure you know what you're doing. Kasaba finds sensitive information on file shares all the time. It doesn't matter how secure the organization claims to be, how great their reputation is. Finding credentials or other sensitive information on file shares is one of our most successful routes of black box compromise. And the transport for a lot of these is oftentimes not encrypted. So that, with instant messaging, a lot of times it's completely plain text, so whatever you're sending can be sniffed. There are some reasonable solutions like off the record, which provides for confidentiality and authenticity via encryption of your message. And it's available for a variety of IM clients. So if you're going to use instant message, consider off the record, also known as OTR. So also, if you are dealing with encrypted files, be aware that when you extract them, they oftentimes end up in a temp folder. So oftentimes you'll have a copy of the plain text on your machine, and you might not even be aware of it. But regardless of the format that we're exchanging, one thing is clear. Oops. And that is, don't rely on the built-in mechanisms of the popular formats to secure your data. So typically, file formats store their encryption keys alongside of the data that they've encrypted. The keys are a necessary component of encryption. It's similar to your house key. And oftentimes this leaves the file vulnerable to compromise. So for instance, I'm sure you know zip passwords can be easily cracked. Excel passwords can be cracked. Same with PDF. Oftentimes the algorithm used to protect the files is weak if it exists at all. So, and obviously flat files and CSVs don't have protection on them. But so what are some suggestions for securing document transmission? For any transfer, your low bar should be strong encryption of the document, so strong encryption of the data at rest. There are a number of ways to achieve this, but for the most part, if you have the motivation, I'm going to give GNU Privacy Guard a shout out. It works well for email, instant messages, file shares, etc. There are some caveats with that I'll get to in a few seconds. Also, you want strong encryption of the connection, so the connection used to deliver the document, so your data in motion. And yeah, unfortunately, this means no FTP. So let's look at the common ways we share data again. And each technology used to deliver content typically has a way to help you achieve the low bar of encrypting the document and the method of delivery. So again, we want to protect the data at rest and in motion. So a few technologies to raise the bar here. I'm going to skip around, but for email, SMIME is a good solution, but we don't see it implemented that often. It's a little hard to manage, as are a lot of the cryptography solutions, but it's a good solution if you do have it implemented. File shares, on Microsoft's platform, you can use Encrypting File System or BitLocker. Apple, File Vault 2, again, deEncrypt for Linux or TrueCrypt. Instant message, again, off the record. And again, GNU Privacy Guard is going to work for most of these as well, all of them. But each technology also has a different level of setup and maintenance required. And since manageability oftentimes drives our decision, that can create some problems. So GPG, for instance, is not something I would recommend without careful consideration of the time commitment to get it right. So that said, I'm optimistic about the future of cloud services because there are some promising secure solutions. And I expect that many of these services will gain wide acceptance, if only for their ease of use. So I'm going to give you some questions that I'm going to give you kind of a way to evaluate solutions, primarily geared towards cloud-based, but you can probably extract the information if you're looking at other solutions as well. So remember that our goal is to maintain privacy, prevent data theft, and to adhere to legal requirements. So here are some questions you can ask. What do you do to prevent being compromised? So every solution must have a story of how they're going to prevent your data from being breached. It's a must. Which hosting providers back your service? So for cloud-based services, knowing which provider is on the back end of a solution can give you an idea of how accessible your data will be, which is also a very important requirement. Accessibility is super important. I've seen companies claim that they offer faster and more efficient services by hosting their own cloud. But consider that companies like Amazon and Microsoft have a lot to lose by not making your data available. So you have a reasonable level of assurance at the back-end provider level that your data is going to be there. So do yourself a favor and choose a known trusted provider. And solutions that use more than one trusted provider are even better for redundancy purposes. Are you able to access my documents? This is another one that gets me. For the most part, you do not want to choose a provider that can access your documents, even if you trust the company. It doesn't make any sense to me why you would want somebody to have the keys to your data. And do you adhere to my legal requirements, my compliance requirements? So this pretty much goes without saying. If they can't help you meet HIPAA or some other mandated requirement, look elsewhere. Let's look at some more specific requirements. Okay, so these come from industry best practices, which are typically based on standards such as those produced by NIST, PCI, FISMA, ISO, et cetera. For at-rest encryption, you need to encrypt with AES 256 at least. And so this is all current. This is what we recommend today. This will change in the future. But right now, this is industry best. RSA 2K keys for signatures. This should last you until about 2030. Sometimes you have the option when you select to create certificates what key size you want to use. And RSA 248 is kind of it's a good bar. If you can choose a 4K key, 4096, you'll be safe. You'll be future-proofing yourself. SHA 256 for integrity checks. MD5 is broken, and SHA 1 is also broken. For in-motion transfers, typically so we're talking about HTTPS. You see this a lot, people talking about securing your transport. So we recommend TLS 1.2, but anything SSL 3.0 is better. I would stick with TLS 1.2. There have been some vulnerabilities in TLS 1.0 and 1.1 that could affect your security. Let's see. If you can pull it off, find a solution that has client certificate authentication. I haven't seen a single solution that offers this for cloud-based solutions. This is akin to what you would get with PGP or GPG with a PKI. So it's much more secure than a password style authentication. And also for these connections, you want a 2K certificate as well. And again, these are the current best practices. So hopefully, if we're asked to come back next year, we'll let you know what the latest is then. Okay. So primarily, again, I'm talking about cloud services. You need to make sure that the cryptographic information is handled securely. So not that when I talk about the cryptographic information, I'm talking about the interim keys that they use while they're performing these cryptographic operations. So you want to make sure that whatever method they're using involves an exchange of public keys. You want to be able to exchange information with people that you want to share your documents with securely. So some way to enable you to locate and exchange your cryptography information with the right individuals. You also want to make sure that the encryption keys are not stored on the provider's site. Again, if the if the service says that they can access your documents, if they say that they have a support feature where you can grant access to their people to look at your documents, don't go with them. You also want to make sure that temporary encryption keys are properly disposed. So this question is more of a technical question that if you ask their frontline people, they probably won't know what you're talking about. But if you can get an answer from them that tells you that they actually are securely disposing of in-memory secrets, then you might be working with a good provider. And you also want to make sure that there's proper access control on your artifacts. So you want to be able to set proper container properties. You want to be able to say that Joe can access the data and Sally can't, or Joe and Sally can access it but George can't. And you may want to be able to revoke access. Certainly, one thing that is becoming increasingly important that I find interesting is two-factor authentication. So I'm sure you've heard of this. Basically, instead of just having one credential, like your password, you'll also maybe have a smart card, or you'll have a phone app, and you'll get a code that you enter as well as your password. And the idea is that somebody can't steal just your password and get access to your information. They have to steal two items. Again, you want to know, you want to be able to set who can access your artifacts, when they can access it. That's another big one, and how long they can access it. So you don't want to have indefinite access to some of these documents. If you're going to delete them, sure, but typically you want to be able to limit their availability. Something else you might want to look for is whether or not transactions are logged and whether or not you can obtain reports. Some other requirements. Artifacts being automatically deleted after a certain period of time, after retrieval. Artifacts being securely wiped not only from your desktop but also in the cloud. So if you store in some sort of blob storage, you want to make sure that in the cloud, you want to make sure that the provider is actually deleting that, overwriting it with some sort of strong method. There are federal methods for deleting files securely. You want to make sure that they're using something like that. But you also want it on the desktop. This goes back to securely deleting files. You want to make sure that if they have a client solution, so sometimes providers will have a desktop version that you can download. And you want to make sure that that desktop version will allow you to securely erase files before sending or after sending them up to the cloud. Let's see. You may want email notifications for file accesses. Something else that's becoming increasingly important is the geolocation of the data. So there are some, I believe there are some federal requirements coming up or that already have been implemented that require you to keep some information stateside. So you may not want US information being stored in Europe, vice versa. So a provider that can tell you where your data is actually being stored is a plus in my book. So and this is all going to give you a reasonable assurance that your data is being handled properly, in my opinion. So let's summarize what we were discussing. First, if you haven't done it already, disable Java extensions in your browser. Drive-by zero-code browser attacks are currently infecting many organizations, and it's not a joke. It happens. It's happening today. But in general, to protect sensitive data, you're going to want to make sure that your organization has a great security policy. And does it adequately protect your sensitive data from breach? You want to make sure that you have an incident response plan, how you respond when your data is exposed. You want to make sure that you have good contracts in place with third parties. You want them to treat your data with care. And remember that this all comes down to you. So transfer with care. You're ultimately responsible for the data that you handle. You want to protect data in motion and at rest with strong encryption. You want to avoid sending information in email or via file shares unless the documents are properly encrypted. You want to use strong encryption for those documents. And again, don't use FTP. It's not secure. When you're done, you want to securely delete the files you've been working with. Don't trust the built-in mechanisms of common file formats. And when evaluating cloud-based solutions, make sure that you use a provider that cares about the security of your document transfer. So don't use a provider that can access your documents. Use a provider that hosts using a trusted backend provider. Use strong encryption, again, in motion and at rest. And find a provider that allows you to exchange keys with your colleagues and verify their identity. That might require a phone call between you two, but it's a good thing to do. Thank you. By the way, I'm going to be posting my notes at kasaba.com, so that should happen in the next day or so. I know there's a lot of dense information at the end there. Are there any questions?
We've gotten some, when I was going to school, we've gotten some laptops from Boeing to practice on and take apart and do whatever with them. And we found out that even though they supposedly deleted their files, they left personal information, including social security numbers and addresses and phone numbers and everything on the hard drive. So other than taking out the hard drive and bashing it with a hammer, how do you know for sure that your data is going to be gone when you delete it?
So the question is, how do you know that information is truly gone from a laptop or a hard drive when you're done with it? There are solutions that you can download that are free, and I'll include this in my blog post as well, that will securely wipe that data. So you can, they do like, I think some of the standards are like 35 passes with encrypted data, and then they'll sync it after each pass and then delete it. So even if someone sees a file name, which I believe they also wipe as well, some of these programs wipe as well, the data is encrypted, or it's random. I'm sorry, there's random data there, so it's garbage. Yeah.
Say your machine malfunction and you gotta go get it fixed. Is there like a way you would advise people on what to do before you bring your computer fixed?
Sure. Okay. So the question is, if your computer is on the fritz and you want to get it fixed, what's a good way to make sure that your data isn't compromised when you send it out for repair? So that's a tough one, because a lot of times the problem is the operating system and not the hardware. If it's the hardware, first you can one thing you can do is take the hard drive out and then send them the machine without your drive, right? And if they say, well, the hardware looks fine, it's the software, and so you need to be able to provide them with the operating system. I guess that's a tough one. So I think that your best bet would be to remove the sensitive information from the computer first and back that up locally, and then securely delete it from the machine before you hand it to them. That's probably not practical. So,
Putting them the password, because you could have administrator instance and your own personal instance. Is it sufficient to just like not give them not forking open the password for them to get to the profile that has the most sensitive information? Does that work?
so are you asking if someone could access another account on the computer after you gave it to them?
Yeah, like it's my Mac. I need to send it to fix.
Mm-hmm.
So it's a video card issue.
Mm-hmm.
I'm sure I have to send it as is.
Yeah.
iMac.
Sure.
Take the hard drive
Mm-hmm.
out. I know that they're going to ask me for password just to get on and stuff. So is that a secure? Is that a foolproof way of not breaching my?
No. I mean, pretty much you can assume that if they have access to your account, you can pretty much assume that they're going to have access to your data as well. Even if it's not the administrator account, there are a number of different ways that you can obtain administrator or root access on the box, even if you don't have them to begin with. Usually it's as simple as a boot disk. So.
Is that tough? I mean, isn't that something that there should be standard? Like the people who repair computers, do they have some kind of like a pledge that they're not supposed to do such thing? It seems like it's a transaction that's going to happen to most people.
Yeah, it's kind of like getting your car fixed. I mean, if you're not going to, yeah. It's scary. There's not a great solution for it. I mean, it helps to kind of to figure out how to do it for yourself. I mean, if there's a problem, a lot of times I know it's not a great answer, but a lot of times if you can just reinstall the OS, or if you can run a repair utility, that will help you. If it's a video card issue and you can remove the hard drive, do that. That would be my suggestion. Sure. Yeah, so start from the beginning, start separating your data. That's a great idea.
Separating the data, have it partition a different part of the hard drive.
Sure, that would work. You could also keep it in a secure container. So make sure that you're only accessing secure volumes, so encrypted volumes, like on macOS File Vault 2. I believe will let you do that once you mount a drive. Yep.
No USB, portable ones. They have now where you could have encrypted some information in there, and some are free. Is that still secure, or that's still just?
So the question is the software that comes with USB keys that encrypts data secure? I can't comment on all of them. I would not trust it. Typically, it's something that somebody can reverse engineer pretty easily, and again, it's going to be some sort of solution where the algorithm that's being used is known, and so they can, if it's just a password kind of system, if it generates a key, if it generates a key for your workstation exclusively, then it may be a good solution. But typically, those pieces of software, I believe, allow you to have a passphrase or something like that, and so it's pretty easy to, well, I wouldn't say easy, but it's possible that somebody brute force the password and get your data. So, yep.
How do you strike a balance between security and ease of use? A lot of the things you talked about seem like they would really block workflow.
Right. So, and this is why I think the cloud services are going to be a lot more popular because they're trying to, it's a lot easier to work with files in the cloud. That's a hard question. So really, how do you strike a balance between security and usability? That's one of the great questions of security. I think there are some solutions that, like Box, that allow you to collaborate and set properties on containers and transfer somewhat securely. Unfortunately, Box is one of the providers that escrows your key. So that's, for me, that's a no-no. But solutions like that, I think, will start to bridge that gap a bit, because for me, Dropbox is so easy. I just drag things to a folder and it's there. But with Dropbox, you're copying a file that's not going to be encrypted. You're copying an unencrypted file to a container that's not going to be encrypted in the cloud. I think they might have a pay solution that's encrypted, but yeah, there's always a management headache. So it's a difficult problem to solve. Yep.
Do you have any recommendations for, I have some colleagues that aren't quite technically savvy that like to email sensitive information.
Yep.
So I'm having some issues with convincing them that we should be encrypting our email. I think there's a roadblock there with their skill set. So are there any solutions that you recommend?
Sure. There's Hushmail, which is a free solution. There are a few others as well. I'll post those on the blog as well. But Hushmail. What's that? Oh, I'm sorry. So the question was, how can I securely exchange emails with someone who might not have the expertise to set up a complicated system? And so Hushmail is a pretty straightforward system. It's kind of like a Gmail type interface, and you type in your plain text, and then it encrypts it for you, and you have a key that's assigned to you, and they have a key that's assigned to them, and there's a trust verification that takes place, and then you can send your encrypted documents to them, and I don't believe that they store any of that unencrypted. So that's one solution. There are a few solutions that are like that. So. Any others? Any other questions? Okay. Well, thank you very much. I appreciate your attention, and have a great rest of your conference.